Alrighty, today we are trying to find missing values using the remainder theorem. So we're using the fact that the y is the remainder. We're using this fact to do these problems. So if x minus 1 is a factor of this function, what is the value of k? So if x minus 1 is a factor, that means if I plug in 1, I should get y is 0 or f of x is 0. So we know that this value should be 0 because it is a factor. So it's 0 equals, and so if I plug in 1 for values of x, and now I just solve this equation. So this is 1 minus 3 plus k, so negative 2 plus k, and then add 2. So 2 is k. Done. Okay, and then you can do k, and then you can do whatever you want. After, like if there's more of a problem, you can do that. So this is the same question, so a quick reminder that if I plug in negative 3, because x plus 3 is a factor, I should get 0 for f of x, or y. So now I'm going to plug in negative 3. And now we just solved this equation. Now you have to know your order of operations or be able to plug these in correctly. So this right here should be 27 minus 3. So it's 24 plus k. So k is negative 24. Yay. Okay. Okay, so now we're going to look at it this slightly different way. Now instead of them, giving you the factor, they give you a root. It's actually, you have to do less. So a root, it's the same situation. If it's a root, then when you plug that in, you get 0. I don't know how this changes like this all the time. Like, it's just so weird. I just moved it up. Why? Anyway, so this is 0, and when I plug in 2, so I don't have any solving to do. I don't have to change signs because it's already solved. This time, however, they're putting k is like the b value. It's next to an x. So it is, I'm plugging the 2 in for x and k. I like writing it like that better. You could write k, times 2 minus 18. It's just sometimes it gets a little confusing. So you got to do the math here. So this should be 16. And then plus 2k minus 18. And that you're just solving. So I don't need to overdo this. So 2 equals 2k, divide by 2, and k is 1. All right, so that's if they're roots or factors. You know that this part right here, that's going to be 0. The h of x or the f of x is 0. Now, another way to use this is the fact that since y is the remainder, it doesn't always have to be 0. So in this case, the remainder is 12. So that means y is 12, or p of x, or f, whatever letter they choose to use. So that means instead of 0 here, I put 12. And for this one, they're saying x plus 2, so we know this is x equals negative 2. So I'm plugging in negative 2 for, I'll do it like this, x. And then we just do the math. So this is negative 8 plus 2k. So this time there's a 12 over here. So combine my like terms. And a little messy there, but whatever. K is 9. That seems good. Seems good to me. All right, that's the idea. And one more example with the remainder. And here we go. So x minus 9, when I divide by x minus 9 into that function, I get 53. So that means that I am plugging in 9. And when I do that, my y value is 53. So 53 equals 9 squared minus 3 times 9 plus k. This one's a little easier because the k is just by itself, no real dividing needed. And we just solve. 81. Look at that. All that work and we get all those big numbers and you get -1. Funny. All right, that's it. Have a great day.